Okie doke. We are going to talk about showing that 3 points are collinear. And collinear means that they're all in a straight line together. Or I guess just a line because lines are straight. There's lots of different ways that we could do this. But we're going to kind of keep with our theme for this unit of writing equations for lines. And we're going to use that method. It's probably not the easiest method, but or the least amount of work, but it will kind of track with everything else we're doing. So, all right. So what we're going to do is, if I have 3 points, they're all in a line together, then I should be able to pick 2 of them and write the equation of a line that passes through those 2 points, and then I should be able to plug in the x-coordinate for the 3rd point, and it'll output the y-coordinate for the 3rd point. Right? So if I well, let's do it and see how it works out. Okay, so we're going to start with calculating finding the equation of the line that passes through points A and B. All right, so we're going to start by find slope of AB. So let's see, we have our change in y and our change in x. I'm just going to kind of skip some steps I have been following. I'm going to calculate them separately and then do the fraction. I'm just going to calculate them all together here. Remember, change is end minus start equals change. So for a change in y, it's 5 minus 3 if we're going this direction, right? Which it doesn't matter. We could go the other direction, but we get the same answer. And for the change in x, it's 5 minus 2. So 5 minus 3 is 2, and 5 minus 2 is 3. Okay, so now we've got to write our equation. Write the equation. We're going to use that point slope form. So y equals m x minus h plus k. And remember, m is the slope and hk are the coordinates of a point that's on the line. I could pick either a or b. It wouldn't matter. So y equals, our slope is 2/3 x minus, we'll pick a. So our x coordinate is 2 plus, let's see here, our y coordinate is 3. There's our equation. And we could turn this into slope-intercept, I suppose. Why not? So that's 2/3 x. 2/3 times negative 2 would be minus 4/3 plus 3. That's 2/3 x. And let's just let the calculator do the heavy lifting for us. So what is negative 4/3 plus 3? 1 2/3, which 5/3. Okay. So plus 5/3. So there's our equation. Now we're going to check the point 8, 7. So we're just going to plug in 8 into our equation and see if it outputs a 7. So y equals 2/3, that was our equation, times 8 plus 5/3. We'll see if this outputs a 7. Y equals 2/3 times 8 is 16/3 plus 5/3. And thankfully these have a common denominator, so 16 plus 5 is 21. 21/3, which in fact is 7. So input an 8, output a 7. Check. Point C is on that same line. So we essentially wrote an equation for the line that passes through A and B, and we checked, and C is on that same line. So A and B are on a line together, C is on the same line, which means they're all on the same line together. I didn't have to pick A and B. I could have picked B and C and then checked A. I could have picked A and C and checked B. It wouldn't matter. Right? Let's do one other example just to kind of show how this would work if they weren't collinear. Okay, let's go here. Let's pick, this time we'll pick these 2 points, E and F. And I think if you look here, you can kind of see if I were to continue this line, I'm going to miss D. So let's check. First of all, let's find slope of EF. So I've got our change in y over our change in x. If we're traveling this direction, end minus start, 7 minus 5 for the y, and 20 minus 16 for the x. 7 minus 5 is 2, 20 minus 16 is 4, so the slope is 1/2. Okay, so next, write the equation. So our equation will be y equals mx minus h plus k. Y equals, our slope is 1/2. X minus, let's pick, I don't know, e, x minus 16 plus 5. Okay, now we're going to take our equation and put it into slope-intercept form, just kind of simplifying things. Y equals 1/2 x, distributed property, 1/2 times 16 is -8 plus 5. Y equals 1/2 x minus 3. So there's our equation. And then we'll check this point here, 13.3. That's D. So we're going to check 13.3 to see if it's on that line. So we'll plug in y equals, actually, let's just, over here for the check, we plugged in, we solved for y, we got y equals 7, we showed that it was true. Let's do it slightly different here. We're just going to replace y with 3 and x with 13 and see what happens. So we'll replace y with 3 equals 1/2, 13 minus 3. So I'm plugging in x here, y here, and if we end up with a true statement, then check the point works. If we end up with a false statement, then no go. So 3 equals 1/2 times 13 is 6.5 minus 3. And we see we have a problem already. 3 equals 3.5, which is not true. So no. Which means that the point D is not on the line that has E and F. And there's only one line that connects E and F. And if D is not on it, then it's impossible that all three are on the same line together. Again, the procedure we use to do this is I pick two of the points, doesn't matter which two, and I write the equation of the line that goes through those 2 points. And to do that, I have to first find the slope of the line, and then I use point slope form to, and either one of the points, it doesn't matter, to set up my equation. I then simplified it into slope intercept form, which isn't 100% necessary, but it looks nicer and cleaner, so I think it's good practice. Anyways, and then we check by either A, we could plug in the x coordinate for the point and then work it out and see if we get the y coordinate for y in the end. And over here we did something slightly different. We plugged in both the x and y coordinates to see if we had a true statement or not. If you imagine on this first one, see how we plugged in 3 and 13 and we got a not true statement? If we had done the same thing up here, instead of writing y all these times, I would have just been writing 7 all along. And at the very end, I would have come up with 7 equals 7, which would be true. Check, it works. So both those methods are pretty much the same thing. All right, and that's how we show if 3 points in the coordinate plane are collinear or not. Keeping in mind that there are many different ways of showing that, and this is just one method, and which is in keeping with what we've been doing recently. So I would keep going with that.